Welcome back, everyone. Um, in this video, I will continue with the previous video about the logistic equation. So after to prove to you the formula of the logistic equation, we will use it and apply to solve our word problem. So let me read the word problem to you. 200 fish were put into a lake whose carrying capacity for that species is estimated 10,000. The number of fish quadruples in the first year. Find a formula related to P population. The numbers of fish in the lake with T years since the fish were introduced. How many years it would take to have 5,000 fish in the lake? So that is the first question. The question asks for how many years in the lake will have 5,000 fish. But first they ask to derive a formula. Okay, so let record whatever is we know in the data given, right? So given P0, like when they first introduced 200 fish, whose carrying capacity for that species is estimated 10,000. So we know that our carry capacity is K equal 10,000. The number of fish quadruples in the first year. So T after 1 year, the number of fish, so like the P at the end, right, equal quadruple. So at the beginning it's 200. Quadruple means bigger than 4 times, so it's 800. 200 times 4, 800 fish. Now, write a formula related to population. The numbers of fish in the lake with the T years since the fish were introduced. In this question, to save our time, I already show you how we derive the formula. So now we just use it, right? So and in our specific scenario here, right? So we have the formula. Now let's write out the first one is PT equal the R rate population time with the P population and 1 minus P over K. So that's the first one. Then from this, we integrate both sides and we derive the formula, which is I already showed you in the previous video. And we come up with the formula K over, actually, PT equal K over 1 plus CE minus R times T. Okay, so now this is the formula we want to use. So let's establish what we know from here to figure out what we're missing. So we have, I'm going to substitute the left-hand side PT here with, at the beginning, 200 fish were put into the lake. Okay, so at the beginning, we have 200 fish put into the lake. So the population of the fish in the lake is 200. And our carrying capacity is 10,000 on the top over 1, follow the formula, C, E minus R time with T. So what do we know about this? At the beginning, when the 200 fish put in the lake, at that time, the T equals 0. So it means this formula will become 200 equal 10,000 divided by 1, adding with C e to minus R times with 0. So the whole thing here will become 0. So I can write as C e to the 0. So with that will give us e to the 0 is 1. So we can cancel that. It's like 1 as C. So kick this bracket down here, up here. Multiply, divide, become multiply. 200 times with 1 plus C equal 10,000. Right? So that's how we solve the equation. I like the fact that I just remember whenever I move the expression or any number from one side of equation to relocate to the other side, kick up to the other side, I reverse the operation. And therefore, I don't have to do, go through a very long way, multiply both sides by and divide both sides by, because that is so much similar, right? You just kick this up here. So this number will time with this root, divide become multiply. Instead of multiply both sides, and then we have to cancel anyway. So that's my, it's just my my thinking, like my own habit, right? Now everybody have their own habits. It depends on they learn in a long way or they learn in a short way. And sometimes even though your method is long, but it might become short because you're familiar with it and you do it in a quick way. So, but let's talk about this. So now I'm going to kick this up, right? And that's what I got here. 200 times with this equal 10,000. So now I'm going to solve it, right? So distribute, I have 200 times 1 is just 200. Adding with 200, C equal 10,000. Sorry why I do like that. I think this is not a good move. I'm going to divide this, right? Now I'm going to divide this by 200. So this gone. See, multiply now become divide, right? So now I ended up with 1 as C equal, cancel, 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 cancel. I have 100 divided by 2 equal 50. Now I'm going to move the number 1 over. So C will be equal 50 minus 1, and that equal 49. See, if I move a number from the other side of the equation, I change the side, but positive become negative. So now I got C equal 49. So now we know C. Now I'm going to put back into 200 equal 10,000 divided by 1 plus C, and we know C is 49, so I put 49 times with E to minus R. The rate of R at this moment, we still don't know, right? We know C, we solve for C, we know C, but there's another letter we don't know. So we have to do another operation. And that is the R here, the rate of rho here, we don't know, right? And the T here is 0, and that's what we get. So now we know C. Okay, so we substitute C by 49 and we have minus RT. Now, at this moment, we have to solve for R. So we know C already, but we need to know R as well. What R will be equal? And how do we do that? So to solve for R, you have to use another information, right? It say, write a formula relating. So this is the formula. So this equation A, actually, I already write here. So then I should put this is the answer for A, right? And then the B, how many years it will take to have 5,000 fish in the lake? So we want to know how many years it will take to have 5,000 fish in the lake. But before we answer this question, we also have to figure out what our rate of growth is. And how do we figure out an R? Well, we can do the same, which is this T here can be substituted by 1 year, right? Because we know that at the time when the number of fish quadrupled in the first year. Actually, I don't think so. Okay, just leave it for now. Just say this is minus 40 RT. Now we know R by figure out that the number of year is the number of fish is quadrupled, right? So we have 800 fish, and that takes 1 year to go up to here. Now, as long as we have an equation with one unknown, we'll be able to solve for it. The fact that we know C already, now we just need to find R, so it's easy to solve, right? 1 at 49 E minus R times with 1 year. After 1 year, the fish get population up to 800. So now I'm going to do the same, right? I'm going to kick this up. So 800, I'm going to kick this up here. Time with divide become multiply. 1 adding 49. A minus R will be equal 10,000. So now I want to solve for the R. I have to isolate this bracket. It means I have to kick this number to the other side. So now, again, I'm going to kick this 800 down here, right? Multiply. Now, kick to the other side, become divide. And I like this. This is so easy. You just put it backward and forward, right? Left and right, and sometimes multiply, sometimes divide. So we're going to cancel 0, 0, 0. 100 divided by 8. So when I kick this down here, I should get rid of up here, right? Because it moved from there to down here. So now I have the equation 1 adding with 49E to minus R equal. Let's figure out this number. 100 divided by 8. So I got 12.5. So 1 plus 49 e to the power minus r equal 12.9. We'll have to move this. Now I'm going to solve for r, right? So let me write down 1 plus 49 e to minus r equal 12.5. Move this number 1 and positive become negative, subtract. Then I get this number is 11.5 and this is gone. This is 49 e minus r, right? Now I will take ln both sides. So I have ln of 49. No, before I do this, so I have 49e minus r equal this number, right? So now to solve for e minus r, I divide 11.5 will be divided 49. So 11.5 divided by 49, I got e to minus r R equals 0.23469, blah, blah, blah. Now to figure out R, I will take ln both sides. So ln e to minus R equal minus R equal ln of this number. So ln of this number is 0.234693876. I try to be accurate as much as possible. We can round up actually. So it become minus 1.449, which is I'm going to round up, become minus 1.45, right? That's on my calculator. That's minus 1.45. Now, because they're both negative, I'm going to make it become both positive, right? Whatever you do to the left, the same like you do to the right. So this R is this number. So now, we're going to figure out how many years it would take to have 5,000 fish in the lake. 5,000 fish, we want that. So our B answer will be 5,000 equal 10,000, follow the formula. Divide by 1 plus with C is 49. E to minus R, we know R now is minus 1.45. Time with T, we want to know T, right? So again, it's just a matter of solving equation, right? So I'm going to do it the same. I'm going to kick this up here. So I have 5,000 times with 1 plus 49 e to minus 1.45 t equal 10,000. Now, when I bring it up here and I multiply like that, it gone, right? Down here, it gone, it jump up here. So now I'm going to divide both sides by 5,000, right? So that gone. So cancel, 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 cancel. 10 divided by 5 equal 2. So now I have 1 adding with 49, e minus 1.45 t equal 2. And I move the 1 over, so minus 1, and that gone. So I left with 1. So now I'm going to iterate this, continue with our equation. What do I get? Okay, so I get 49 now, e to minus 1.45 t equal 1. Divide both sides by 49, that gone. This is 1 over 49. So 1 divided by 49. I get this is 0.02. We will round up, become 1. So now I take ln both sides. Then I have minus 1.45 t equal ln of this number. So now I'm going to solve for t, right? Okay, so it means I will divide this by minus 1.45. And I cancel that. So t now will be equal to this, divided by that. So ln 0.021 divided by minus 1.45, enter. I got this number t equal 2.66. You can see that on my calculator, right? 2.66 for whatever, but we're going to round up. T will be equal 2.7 years. That is the answer for the B question. So now we know if we want to have 5,000 fish in the lake, the answer will be, the time will be 2.7 years. That is very cool, right? Okay. So I hope you enjoy. I don't know if I go too fast or not, but I don't think so, right? My teaching is kind of very slowly. Okay. So now let's see what we're going to do. There's one last question, right? One last question. And that's getting very interesting. So let me read the question C to you. So now you know the answer for B is what? It takes 2.7 years to have 5,000 fish in the lake, right? So now we're going to do C. Let's read the C. When there are 5,000 fish in the lake, so we get up to there already. Now we have 5,000 fish in the lake. The fishermen are allowed to catch 20% of them. How long will it take for the population to increase to 5,000 fish again? All right. So it means we know it takes 2.7 years, but then after it hit the maximum number, the rule is say, as long as in the lake have 5,000 fish, you can catch them. If it's under that, you cannot catch them. The reason because they don't want the fish go extinct, right? So that's why they want to keep at least enough, a certain number for them to take time for them to reproduce another 5,000 or whatever. So that's the way it is, I guess. So now we want to figure out what is 20% of 5,000. So we say 0.20, I divide this by 100, times with 5,000, and see how many fish is that. So the fishermen are allowed to catch that, right? So we say 0.2 times 5,000, and that equals 1,000 fish. So now we will say, okay, we want what? 4,000 fish. Because 5,000 minus 1,000, right? Because they catch 1,000, so there's only 4,000 fish left in the lake, right? 4,000 fish left because they catch 1,000 of them. How long will it take for population to increase to 5,000? Now, this is a little bit tricky, but not too bad. If we know the formula, all what we have to do is figure out how long for the fish go up to 4,000, right? And then we know that it takes them 2.7 years go up to a number amount of 5,000. So let's figure out 4,000, okay? So 4,000 equal 10,000 divided by 1, adding with 49, e to minus 1.45 t. So now I'm going to kick this up again, right? Go up here, divide become multiply. So 4,000 times with 1 plus 49 e to minus 1.45 t equal 10,000. So now to get this alone, I have to cancel that and bring it down here, which is multiply. When it go down here, become divide, right? Reverse operation. So now cancel, 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 cancel. 10 divided by 4. 10 divided by 4. I get 2.5. Okay, so this number 1.49 e minus 1.45 t equal 2.5. Now divide, subtract 1, so that equal 1.5. So now this 1.5 will divide by 49. So that gone, that gone. So I have e minus 1.45 t equal 1.5 divided by 49. I got this number 0.03 and 06. So I'm going to round off, become 1. So now take log both sides. I will have minus 1.45 t equal this. So to solve for t, I'm going to take log of this number and divide this by 1.45 again, minus. So when I divide this gone, t will be equal ln 0.031 divided by minus 1.45, I got this number equal 2.395. So that's on my calculator, right? So now, okay. So this is 2.7 year, yeah, I record here. So now I have, to get up to 4,000 fish, it required 2.39. So let's draw up 2.4 years. Okay, so the time elapsed between them. If it takes 2.7 years for the fish to grow up to 5,000, right? And for the 4,000, so we just say if it's 5,000, and I shouldn't write like that. It looks confusing, right? So I'm going to say if 5,000 fish, then it took 2.7 years. And when there are 1,000 fish in the lake, the fishermen are allowed to catch 20% of them. How long will it take for the population to increase back into 5,000 fish again? So now, if it is 4,000 fish, it took 2.34 years, right? It said 2.4 years. Now, the time elapsed between this and this, because we base on the assumption that we're going to use this formula regardless the destruction of the environment, up and down, the weather, climate, or whatever involved factors, we are use this. So it's going to be routine. It's going to be not going to be changed. We assume it based on our assumption that it always takes 2.7 years if we want the fish to grow from a 200 up to 5,000. And it always 2.4 years if we want the amount of fish in the lake is 4,000. This number is routine, repeated eventually, right? So when we say, okay, so if it's 4,000 fish, it takes 2.4 years. Now, if we want to build back to 5,000 fish, the difference is just 1,000, right? So we're going to subtract these two numbers, right? Because that's like a time elapsed. So this becomes 0.3 years, the time elapsed, right? So time elapsed will be equal to this. And we don't like this because say 2.3. I'm going to say no 0.3. I'm going to time with 12 months, okay? So because this is the year, so if we time with 12 months, we say that it's about 3.6, which is like 4 months. So if the number of fish is be catch by 1,000 down from 5,000 to 1,000, then the amount of fish, if we want to gain back to 5,000, will be this year, subtract this year. So it will be about 4 more months so that we can have a fish go back to the 5,000. From the 4,000, go up to 5,000 level again. So that's it for the lesson today. So I hope you enjoyed this short video. Actually, none of my videos are very short, right? Because we went through the word problem, we read it, we explain it, and we develop the formula and blah, blah, blah. So, but anyway, I think that you will learn something out of it. Now, if it's so fast, because see on YouTube and I show you, right? But if you enroll in my course, you have all the materials, right? All of this written down and you will follow along with it and watch my video, lecture video, my explanation, and you can go slow but on your own. You can rewind the video and you can rewatch again and again. So it actually is not too bad. It still have, if I had to watch here like the way I learned before, now I found like the words now is so amazing. We allow for a teacher like me can standing here and teaching you guys um, without have to go to school. Now, of course, there's still a time when the teacher have to be in the school and teaching student. But however, we also provide opportunity for all of us to learn and grow. And that is how advanced technology added into the development of education give us the on the opportunity we can learn. So it just like I found it fascinating and it just wastes our time. We don't want to learn. To be honest, that's how I felt, right? So like I standing here and you still can learn it at home or whatever. But also, if you enroll to my course, which is affordable, it's not too expensive, to be honest with you. It's not just I'm advertising for my course, but also it for your learning as well, right? You have on the privilege, rewind, see the video, watch more slowly, watching the step back again. And it's so much easy to learn nowadays compared with back in the old time, when we have to try to memorize 500 pages from the biology textbook, or, like had to go through um, one after another, and and um, and some school is far away and we have to walk through some village, have go through the school which is miles and miles, and they don't have vehicles to approach, and some village doesn't have a light for student to learn, and we have to sit on the ground. And actually, like my country after 1975 is almost like that, even though we live in the city. And and so all of this advantage, and I hope that if you can watch this adding with my course online video, and the video is connection step by step, you can learn so much easy for you to understand this calculus. A lot of people, like before, we were very talking about calculus with the weird idea. We don't know what calculus mean, right? It's hard, even though when back in the time when I was learning, this concept is very, very tough to understand. It seems something it's like very abstract ideas, the rate of change, blah blah blah. But nowadays with our technology, with the YouTube, with a lot of things, and every teacher, every professor try to give you good, outstanding performance on the YouTube. Then we make our learning become so easy to learn, to be honest with you. So thanks for the technology to bring the best to our world, and maybe each of the world in our cell, my world as well as your world, um, your family, your member. So we just appreciate what we have now, um, from the people who sacrifice for mathematics, engineer and science, like Steve Jobs developed the cell phones, and now we can use, like I anytime thinking about Steve Jobs, I just want to cry because his life was cut so short, but he contributes so much in our society, right? And that's why I can stand here and talk to you and show you whatever on the board here. Like I just feel like how much people have to satisfy for our generation, for us to appreciate what they have done for us. So anyway, I hope that my video will not so boring in terms of math as well as in terms of my social chat with you sometimes. I try not to go out of the topic too long, right? Whatever, if I am so talkative, I'm going to try to remind me that, oh, you should go back and teach. Anyway, I think I'm done with this video now. And thank you for watching. Stay tuned for our next, a lot more and more interesting lesson coming. Bye for now.